download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support, and so much more. This video is about kinetic and potential energy stores. Now, from last video, we said that any object that is moving has kinetic energy. Now, the greater the mass or velocity of the object, the greater the amount of kinetic energy. And therefore, it can be calculated with this equation here that we do need to remember. This EK here stands for kinetic energy. So EK equals kinetic energy. The half is obviously a half, and to put that into the calculator, we can just put it as 0.5. The M stands for mass, and the V squared stands for velocity, or the V stands for velocity. Okay, now because kinetic energy is a type of energy, the unit of it is a joule. The units of mass are always kilograms, and the units for velocity are meters per second. So we do have to remember this equation and the units for each of the components of this equation. But let's go through some worked examples to help you out. So question 1. Cristiano Ronaldo kicks a football of mass 500 grams at a speed of 40 meters per second. Calculate the kinetic energy of the football. Well, as I always like to do when I get these types of questions, I like to write what I know. So we've got mass here as 500 grams. Now these are where we've got to be careful because the mass we need is in kilograms. So we need to convert from grams to kilograms, and we can do that by dividing it by 1,000. So 500 divided by 1,000 equals 0.5 kilograms. Okay, and then the speed is 40 meters per second. So the speed is 40 meters per second, and it wants us to calculate the kinetic energy. So we've written down the values we've got. Now we need to input these into our equation. So kinetic energy is equal to a half times the mass, which is 0.5, times the velocity, which is 40, and remember it's velocity squared, so it is 40 squared. And if we put this into our calculator, we get that kinetic energy is equal to 400, don't forget the units, joules, 400 joules, and that is the answer to that question. Let's go through a second worked example. So a car has a mass of 800 kilograms and is travelling with a kinetic energy of 1.44 megajoules. Calculate its velocity. So let's write down the values we know. The mass is equal to 800. And this time we've been given the kinetic energy, which is equal to 1.44 megajoules. Now to get from megajoules to joules, we have to times it by 1 million. So times this by 1 million equals 1.44 million joules. And now we have to input these into our equation. So we've got the kinetic energy, which is 1.44 million, is equal to a half times the mass, which is 800, which you get here, times it by v squared, which we're trying to work out. So we now need to get v squared and v on its own. So what we're going to do is we can move the 0.5 to this side, and if it's a times over here, it'll be a divide over here. So 1.44 million divided by 0.5 is going to equal 800 times v squared. If we put that into our calculator, 144 million divided by 0.5 is going to be 2.88 million is equal to 800 times v squared. Okay, so now what we're going to do is we're going to put the 800 over to this side to get it on its own. So it's a times over here, so it'll be a divide over here. So it'll be divided by 800. So they cancel each other out to get v squared on its own. So 2.88 million divided by 800. That gives us 3,600 is equal to v squared. Now, to get rid of the squared, the v squared, we're going to have to square root both sides. So we'll square root 3,600 and square root v squared. So 3,600 squared is 60, and v squared rooted is v. So our answer then for our kinetic energy, our velocity, sorry, is 60, and our units are meters per second. So the answer that we should have got there is 60 meters per second. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. And now let's do question 5. A car travelling at 10 meters per second has a 75 kilojoules of kinetic energy. Calculate the car's mass. So we need to write down what we know. So velocity is equal to 10 meters per second, and that is in the correct units. And then kinetic energy is equal to 75 kilojoules. Now we need to get that into joules. So to do that, we can times by 1,000. So it's 75,000 joules. Now we can input these into our equation. So kinetic energy is equal to 75,000, which equals a half, times mass, which you're trying to work out, times velocity squared, so 10 squared equals 100. And now what we need to do is obviously we need to get our mass on its own. So we can do 75,000 divided by 0.5, and then divide that by 100. And that gives us a mass of 1,500 kilograms. So the mass equals 1,500 kilograms. Gravitational potential energy is the energy an object has due to it being raised above the ground. The greater the height on an object above the ground, the greater the gravitational potential energy it would have. The stronger the gravitational field strength, again, the greater the gravitational potential energy. On Earth, the gravitational field strength is 9.8 newtons per kilogram. So here is the equation for gravitational potential energy. So gravitational potential energy is equal to mass times gravitational field strength times height above the ground. Okay, so EP obviously stands for our gravitational potential energy. And because it's an energy, the unit is in joules. Our M stands for mass. And again, our units are the kilogram. Gravitational field strength is G. So G is the gravitational field strength. And that is measured in newtons per kilogram. And finally, H stands for height above the ground. Above ground. And that is measured in meters. And here is the equation that links all those three together. So let's go through a worked example. The record for the highest hot air balloon flight is 21,027 meters. At this height, the balloon had an estimated 733 megajoules of gravitational potential energy. What was the mass of the balloon? So first thing we need to do is we need to write down all the numbers that we've got. Okay, so here we go. The height above the ground was 21,027 meters. That is the units we needed in, so we can leave it there. The balloon had an estimated gravitational potential energy of 735 megajoules of GPE. So this is obviously in megajoules, so we do need to convert this. We can do this by timesing it by 1 million. So 735 times 1 million equals 735 million joules. What was the mass of the balloon? Okay, now we said that the gravitational field strength was obviously 9.8 on Earth. So we're going to use our gravitational field strength at 9.8. Then what we need to do is input these into our equation. So gravitational potential energy, which is 735 million, is equal to our mass, which is what we're trying to work out, times gravitational field strength, which is 9.8, times by the height, which is 21,027. Obviously now we need to move these across to get to mass on its own. So we can move that across by now dividing it by 9.8 because it's a times on that side. So 735 million divided by 9.8 comes up at 75 million. So 75 million is therefore equal to mass times 21,027. Now we can get mass on its own by getting that over to this side. So it's times over here, so we can divide it. So 75 million divided by 21,027, and our mass is therefore equal to 3,566.8, and our unit is the kilogram. So that is the answer to that question. So let's go through one more worked example. At what height would the same hot air balloon have 50 kilojoules of GPE? Okay, so first, what figures do we know? Well, we worked out the mass of the last one was 3,566.8. Okay, so that's the mass. Okay, and the gravitational field strength is still 9.8. And we want that to have a GPE, a gravitational potential energy of 50 kilojoules. Okay, now of course remember that's kilojoules, so we do need to convert that, so we can times it by 1,000, which will give us 50,000 joules. And once we've written those down, we can input them into our equation. So gravitational potential energy is 50,000, which is obviously here, which is equal to the mass, which is 3,566.8, times the gravitational field strength, which is 9.8, times height, which is what we are trying to work out. So now we need to get height on its own, so we can pull this over to this side. It's a times over there, so we can divide it. So 50,000 divided by 3,566.8 gives us 14.018, is then equal to 9.8 times the height. So now we can put this over to the other side, so it's a times over here, so now we can divide it. So 14.018 divided by 9.8 gives us a height of 1.43. And the units for height are meters. So that is our answer for this question. So at 1.43 meters, our hot air balloon will have 50 kilojoules of GPE. So what I'd now like you to do is try and have a go at these questions, and then we'll go through the answers together. So pause the video now. Okay, so question 1. What type of objects have gravitational potential energy? Objects that are above the ground. Question 2. What is the equation for gravitational potential energy? Well, it's gravitational potential energy is equal to the mass times the gravitational field strength times the height. Calculate the gravitational potential energy of the following objects. So we have a gravitational field strength of 10, a height of 5, and a mass of 20. And you should have got 1,000 joules for your answer there. Question 4, you should have got 10.2 meters. And question 5, you should have got 10.2 kilograms. Okay. The energy stored in a spring when work done in compressing or stretching is called elastic potential energy, and it can be calculated by using the following equation. So we have elastic potential energy is equal to a half times spring constant times extension. Okay, where E refers to elastic potential energy, K refers to the spring constant, and this really refers to how hard it is, measures how difficult it is to compress or stretch a spring. The larger the spring constant, the more difficult it is to compress or stretch. And extension squared, or E, stands for extension. Okay, now elastic potential is obviously a energy, so it's measured in joules. The spring constant is measured in newtons per meter, and the extension is measured in meters. So let's go through a worked example. So number 1, how much work must be done to compress a spring by 4 centimeters if the spring constant is 55 newtons per meter? So let's write down what we know. So 4 centimeters is obviously the extension. Okay, so the extension equals 4 centimeters. However, we need it in meters, and to get from centimeters to meters, we're going to divide it by 100. Okay, so 4 divided by 100 gives us 0.04 meters. Then also we've got the spring constant. We've been given the spring constant. So that is 55 newtons per meter. We can then put these into our equation. So elastic potential energy is equal to 1/2 times our spring constant, which is 55, times our extension squared, which is 0.04 squared, and therefore our elastic energy is 0.044 joules. Let's do one more. So a coil, springs and a car suspension have a value of K equals 64 kilonewtons per meter. When the car strikes a bump, the spring briefly stores 80 joules of energy. How much does the spring compress? Okay, so again, let's write down what we know. So we've got our K value, so our spring constant of 64 K newtons, so kilonewtons per meter. Obviously, we need to convert this into newtons per meter, so we've got kilonewtons, so we can convert that by timesing it by 1,000, which gives us 64,000 newtons per meter. And we've got our elastic energy of 80 joules. Now we can input these into our equation. So elastic energy, which equals 80, is equal to 1/2 times our spring constant, which we've worked out to be 64,000, times extension squared, which is what we're trying to work out. So really now we need to get our extension squared on its own. So we can move this to this side. So it's a times over here, so we divide it. So we do 80 divided by 1/2, which is 160, is then equal to 64,000 times E squared. This is a times over here, so to move it over here we can divide it. So therefore we can do 160 divided by 64,000. So 160 divided by 64,000 gives us 0.0025 is equal to E squared. And then we can square root both sides to get E on its own, which gets E equals 0.05, and the units for it are meters. So what I'd now like you to do is have a go at these 3 questions here, and we'll go through the answers together. So pause the video now. Okay then, so going through the answers for question 1, you should have got 0.025 joules. For question 2, you should have got 29.25 joules. And for question 3, you should have got 0.1643 meters. We have now looked at kinetic energy and its equation, gravitational potential energy and its equation, and elastic potential energy and its equation, and we have worked on practice for each of these. You can now move on to even more practice by using the quiz and the exam questions. And if there's anything you don't understand, then please do get into contact with one of our tutors who will happily help.